All right, here's my third part in this in section 3 of the redesigned SAT practice test 1. In this video, I'm going to do questions 11 through 15 in this no calculator section. So in prior videos, I did 1 through 5 here, and then I did 6 through 10. So picking this up at 11 here. Number 11, you're given B equals this mess, C equals this mess, and then you're told in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. Okay, that's a lot to kind of wrap your head around. X is the number of weeks after July 1st, so something to do with time. B is the price of beef. C is the price of chicken. What is asked is what was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so what you're trying to figure out is how much these things cost when they cost the exact same amount. It's a little bit tricky. There's a few ways you can come about figuring this out. One way to do it is say, okay, let's figure out when they cost the same amount. So let's solve for what X was equal to when B was the same as C. If B is the same as C, then I got 2.35 plus 0.25x. That's what B is. That must be the exact same as 1.75 plus 0.40x. Right? If B and C are the same, this equals this. And so now I can solve for x algebraically. Maybe I subtract 1.75 from both sides, which is a bit annoying without a calculator, but maybe you can figure out that that's 60 cents over here. And then I subtract 0.25x from both sides and get here. And then I have to divide these numbers, so I get that x is equal to 0.60 divided by 0.15. And again, you're not a huge fan of the decimals probably, but you could multiply the top and the bottom of this fraction by 100, and that'd give you 60 over 15, which might be easier to look at. That's a 4 right here. So what we figured out is that these guys cost the same after 4 weeks after July 1st, that when x equals 4, they cost the same. But that's not what the question is asking. It's not saying when did they cost the same. It's saying what was that same cost. So what you can do is take either of these equations and plug in x equals 4. Doesn't matter which one you choose. What I'm going to do is choose this first one because I recognize that what happens to the x is it gets multiplied by either 0.25 or 0.4. And I like multiplying 4 times 0.25 because I know that's exactly 1. So I would say that b equals 2.35 plus 0.25 times 4, which I would say is 2.35 plus 1, which is $3.35. So I get this answer here. That's one way you could do this problem. There's other ways you could do it. You could, if you kind of look at this more like, okay, beef starts out at this price and then increases by a quarter every week, and chicken starts out cheaper but increases by more. So it kind of makes sense that at some point their prices are going to meet each other and cross. So sort of think about what happens after 1 week. Maybe you can make a chart somewhere. I'm sort of low on room on this thing, but I'll try to do it off to the side here. So this is weeks, and then this is beef, and this is chicken. Right? After 0 weeks, the prices aren't the same. They're 2.35 and 1.75. After 1 week, beef has gone up by a quarter. So 2.35 plus a quarter gives me 2.6. And chicken is 1.75 plus 40 more cents, so 2.15. Shoot, they're not equal yet. Well, I guess I have to wait for another week. After another week, this number goes up by another quarter. So what's this plus 0.25 more? Well, it's 2.85. What's this plus another 40 cents? Is 2.55. Shoot, still not the same. I guess I got to add another week. Add another quarter here, you get $3.10. Add another 40 cents here, you get $2.95. And there's no way you can see that, sorry. They're still not the same. Add another quarter here, you get $3.35. Add another 40 cents here, you get $3.35. Hey, look, it looks like the prices are the same. Note that that happened in the 4th week, exactly as we had calculated down here. Another way you could do it is just by listing out the weeks. Another way you could do it is kind of a guess and check. Well, it's going to happen at some point. Maybe I'll guess it happens after, I don't know, 5 weeks. Try plugging in a 5 into both of these equations. What you'll find is chicken cost more than beef. What that tells you is that your answer must be less than 5 because chicken started out cheaper, and so if now it's more expensive, that means those prices have already crossed. So it must happen before 5 weeks. Okay, see what happens after 3 weeks. Oh, beef is still cheaper than chicken after 3 weeks. Okay, I guess it must be after 4 weeks. See what their prices are then. There's a few different ways you could solve this. I don't know. I'll leave it up to you what you prefer. Number 12 here, a line in the xy plane passes through the origin. The origin is the point 0, 0. That's good to know. And has a slope of 1/7. Which of the following points lies on the line? You got a few options, as you do with most of these problems. You could try to graph this thing. You could be like, okay, it goes through the origin, which is 0, 0. And then if it has a slope of 1/7, that means every time it goes up by 1, it goes to the right by 7. So 1, 2, 3, 4, 5, 6, 7. It goes through this point right here. This point right here is at 7, 1. You list the x-coordinate first and the y-coordinate second. Unfortunately, that's not one of my options here. So let's keep looking. Well, from this point, it would go up by 1 every time it goes over by 7. So 1, 2, maybe 7, 8, 9, 10, 11, 12, 13, 14. And then it goes up 1 more. So it's up at this point here, which is 14, 2. Which is on my list here. It's D, so that must be my solution. It's one way you can do it. Another way you can do it, less graphically, more algebraically, is you can say the slope of a line, or the equation of a line, y equals mx plus b, relates together the y-coordinate and the x-coordinate if you just know b, which is the y-intercept, and m, which is the slope. And if you read through the problem, they tell you both of those things. They tell you that the slope is 1/7. So in place of m here, I'm going to write 1/7. I'm going to leave the y's and the x's as y's and x's. Now I need to know what b is. You're like, I don't see any mention of the y-intercept in here. That's true. But if you know that the y-intercept is the height when you cross this y-axis right here, the fact that it goes through the origin tells you that the height is 0 when it goes through your y-axis. So really in this, which is called which is called slope-intercept form of a line, you can write the equation of the line like this, which is really just y equals 1/7 x. And then all you got to do is plug these values in to see which one satisfies this criteria. So try plugging in 0, 7. Change the x's into zeros. Will y be equal to 7? No, 1/7 times 0 isn't 7. Okay, try changing the x's into 1. 1/7 times 1, is that equal to 7? Nope. Okay, try plugging in x equals 7. 1/7 times 7, does that equal 7? Nope, it's not that one. Okay, try plugging in 14. 1/7 of 14, does that equal 2? Yeah, it sure does. That's my answer right there. Another thing that you could do is once you have your equation of the line y equals 1/7 x, you could multiply both sides of this equation by 7 to get the 7y equals x. If you know that 7y equals x, essentially what you know is that the x-coordinate is 7 times as big as the y-coordinate. You could glance at these guys and ask yourself the question, when is the first number 7 times as big as the second number? And you'll see that only happens in part D, or in answer D here. Number 13, if x is greater than 3, which of the following is equivalent? Okay, so you're given this mess here. This gets pretty hairy algebraically. You got these kind of fractions inside fractions. They're called complex rational expressions. The way I like to do these problems is remind myself that I know how to divide fractions. You might be like, I don't know how to divide fractions. Well, hold on, I'll tell you in just a minute. But if you take as given that you know how to divide fractions, then all you have to do is rewrite this so that it's a fraction over a fraction. Writing the 1 up here in the denominator as a fraction is pretty easy. You just write it as 1 divided by 1. Now it's a fraction. Awesome. Down here in the denominator, writing this thing as a single fraction is a little bit trickier because you're adding together these two things. Every time I say fraction, I should be saying rational expression. But I'm guessing you don't care about the terms that I use. You see these things, you know what I mean when I say a fraction. Anyways, to add these together, we need a common denominator. The least common denominator will be x plus 2 times x plus 3. To get these guys to have a common denominator, I'll multiply this fraction here by x plus 3 over x plus 3, and this fraction here by x plus 2 over x plus 2. Note that this thing in red here is just equal to 1. A fraction, when the top is the same as the bottom, is just equal to 1. So I'm just multiplying by 1. I'm not changing the value of anything. That's why I read it all out like this, so I can remind myself that I'm not changing any values. Same idea over here. So what do I have down in the bottom here? Well, now I have the same denominator here as I have over here. I have a common denominator. And when I have a common denominator and I'm adding, I add up the numerators and I write the denominator once. Like if you had 1/7 plus 2/7, what you would do is you take the 1 plus 2 and add those together to get 3. You wouldn't add the 7th, you just write the 7 one time. You don't add the denominator, you get a common denominator so that you can just write it a single time over here. I have this common denominator, I'm just going to write it once, this x plus 3 times x plus 2 thing. The numerators I have to add just like I added this 1 and this 2. So I got x plus 3 plus x plus 2. So you get this mess here. This is a fraction divided by a fraction. Before I show you how to divide fractions, I'm going to simplify a little bit. So I'll leave the top completely alone, 1 over 1. Down in the denominator here, I'm going to say x plus 3 plus x plus 2. I can combine like terms. The x and the x give me 2x. The 3 and the 2 give me 5. Down here in the denominator of my denominator, I have x plus 3 times x plus 2. If you multiply those together, maybe you're familiar with the acronym FOIL. You take the first, x times x to get x squared. The outside, x times 2 gives me 2x. The inside, x times 3 gives me 3x. 2x plus 3x gives me the 5x. 3 times 2 gives me 6. So I get here. Why did I combine like terms and FOIL these out? Because I glanced over at the answers and I didn't see any parentheses over here. I noticed that they don't have this in a factored form, that they have combined like terms and factored things out, so it got me into this. I don't see this over here, but now I have a fraction divided by a fraction. And the way I divide fractions is a lot like multiplying fractions. You just multiply by what's called the reciprocal of the denominator. You take this thing down on the bottom, and you change it from a division problem to a multiplication problem by flipping this thing upside down. So instead of 2x plus 5 divided by x squared plus 5x plus 6, you can write it as x squared plus 5x plus 6 divided by 2x plus 5. And if you're just multiplying by 1, it doesn't change the value of anything. You get x squared plus 5x plus 6 divided by 2x plus 5, which is exactly what you got right here. That's a lot of algebra. Could you have gotten there quicker? Yeah, probably. You could have not written this as 1 over 1. And I said 1 divided by a fraction means the reciprocal of that fraction. So that's why you're flipping the bottom upside down here. That's why I end up with just this thing upside down. The reason I did this slightly longer way is what if this wasn't a 1? What if this were an x or a x plus 2 or something? You could still do this method. So I wanted to give you a more general solution that would work in lots of problems. I bet there's a lot of people taking this test that looks at this and they're like, yeah, I'm not going to figure this out. I'm taking the SAT this weekend. It's not going to happen. My algebra skills, it's not going to work. What else could you do here? Well, a strategy that would work, it's not the best thing in the world, but it would work, is to plug in some values for x. You might get lucky, you might get unlucky. This says that this is true if x is greater than 3. So maybe plug in x equals, I don't know, 4? What happens when x equals 4? If x equals 4, I would have 1 divided by, and then 1 over x plus 2 is 1/6, and then 1 over x plus 3 is 1/7. So I have 1 over 1/6 plus 1/7. That's kind of ugly to figure out. I'm going to have to do some steps to simplify this thing. But before you even simplify that a whole lot, let's look at what these other answers are. 2x plus 5. If x equals 4, this is 13. X squared plus 5x plus 6. If x equals 4, this is 16 plus 20. So I'm already up to 36 plus 6 more. What's that, 42? This number is not going to be nearly this big. 1/6 plus 1/7. I mean, this is, if they were both 1/6, 1/6 plus 1/6 would be 2/6, which is a third. And 1 over a third is 3. These are way too big to be equal to this. It's just not going to work out. So you can cross these guys out even if you can't do the algebra. And then maybe you could kind of guess between the two of these. You've narrowed your choices down to a 50-50 shot. I guess you could try plugging in 4 in these two equations. I think what you'll find is that in this equation you get a number that's larger than 1. You get 42 over 13. Whereas in this one you get a number that's smaller than 1, 13 over 42. This one you get 13 over 42. This one you get 42 over 13. And I know that because the top here is this 2x plus 5 and the bottom is the x squared plus 5x plus 6. So then all you got to figure out is this thing right here. Is it as big as 42? No, I don't think so. Is it as big as 13? No, I don't think so. Is it less than 1, like 1340 seconds is? No, it's not, because this number down on the bottom is less than 1, and 1 divided by something that's less than 1 is going to be greater than 1, so it can't be this answer either. One way you get here with process of elimination is by doing something like that. It's not the prettiest solution in the world. One last thing maybe before I move on is you could also simplify this here. You could say my least common denominator here is 42. So I have 7 40 seconds plus 6 40 seconds. So really I have 1 over 13 40 seconds, which as we saw above was 42 thirteenths. So when x equals 4, which I just kind of chose arbitrarily, there's only one solution that I'm able to eliminate 3 of the 4 solutions, I guess is what I'm saying. All right, that's more than enough on 13. Moving on to 14. 3x minus y equals 12. What is the value of 8 to the x power divided by 2 to the y power? All right, this is a pretty tricky problem. What I would do if I were given this is I would take this equation and I would say, okay, let's solve for one of the variables. This tells me that if I add y over to the right-hand side and subtract 12 from both sides, I get 3x minus 12 is equal to y. So then I can rewrite this thing so that it only has one variable in it. I can say 8 over x is the same as 2 over, or not is the same as, sorry, I'm trying to figure out what this is equal to. 8 to the x power divided by 2 to the, and then instead of writing y, I'm going to write 3x minus 12. I'm going to write this thing here. Okay, so how does that help me? Well, you might notice that 8 and 2 are related, that 8 is a power of 2. In fact, 8 is exactly 2 cubed. So I could, instead of writing an 8 here, I could say this is 2 cubed to the x power divided by 2 to the 3x minus 12 power. Why would you do that? Well, if you have the same base, there are rules, there's exponent rules that allow you to simplify this thing. So instead of writing 8, I write 2 to the 3rd power, so that now my base is 2 both in the numerator and the denominator. How would you know to do this? I don't know, you probably wouldn't, but I'm giving you some examples, so maybe if this pops up, you know what to do in the future. There's an exponent rule that says when you're raising an exponent to another exponent, you multiply those two exponents. The top is 2 raised up to the 3 times x power. It's a little bit counterintuitive that this equals this, but it does. And this is 2 to the 3x minus 12 power. Okay, so I'm getting better. There's one more rule that I need to know. When you're dividing and you have the same base, all you got to do is subtract the exponents. So I have 2 raised up to the 3x power minus this 3x minus 12 thing. That when you're dividing and you have the same base, you subtract the exponents. I can simplify that. Instead of 3x minus this entire thing, I have 3x minus 3x, which is 0. And then minus negative 12 gives me positive 12. This entire thing simplifies down to 2 to the 12th power. You'll see that that is exactly what you have for answer A up here. It turns out that that is different from answer B and answer C. So it looks like the correct answer is given to you here as 2 to the 12th power. Other ways of doing this, man, I don't know. It's a pretty tricky problem. I'm sure there are other ways you could solve this thing, but I think I'm just going to call that good and move on to number 15. Okay, number 15. Number 15 is a hard problem for sure. There's a few different ways that you can solve this problem. What I think would probably be the quickest way to solve this problem is to plug in some values. So when you're told that this equals this for all possible values of x, that tells you that you can plug in whatever the hell you want for x, and this will be the same as this. So often what you want to do is plug in x equals 0. In this case, that won't help, because if you plug in x equals 0, this just simplifies to 2, and this is 7, and this is 14. You lose all your a's and b's and c's, which is what you were asked about in the first place. So unfortunately, that doesn't help. What about if x equals 1? Well, if x equals 1, I got a plus 2 times b plus 7, and that must be equal to 15 plus c plus 14. Right? So what I did is I took x and set it equal to 1 because that was the easiest for me to do in my head, and got here. But really, what is this saying? A plus 2 times b plus 7 is equal to c plus 29. So I guess I could say a squared plus 9, nope, that's not true, plus 7a plus 2b plus 14 is equal to c plus 29. And you're like, wait, what's going on here? Now you just got a bunch of letters floating around. How does that help? Well, a plus b equals 8. I know that much. So what are some possible values of c? So maybe at this point we take one of these and say, could c possibly be equal to 3? Fuck. Okay, and number 15, this problem is a mess. I think, well, here's one way you could solve it. If you look at this thing on the left here versus this thing on the right, they look nothing alike, right? This is the factored form, this is the expanded form. So let's get them to look similar. Let's FOIL this out. I do a times x times b times x, which would give me abx squared. And then ax times 7 gives me 7 of these ax things. And then bx times 2 gives me 2 of these bx things. And then 7 times 2 gives me 14. So if this equals this, then this mess right here must also equal this. But think about what that tells you. My only x squareds come from this term on this side and this term on this side. So if these two things are the same for any value of x, then AB, my coefficient on x squared over here, must be the same as 15, my coefficient on x squared over here. What about my coefficient on x? Well, I have a c over here. Over here I have a 7a and a 2b. So 7a plus 2b must be equal to c based on the x terms. And then 14 has to equal 14. That doesn't give me any information, so I'll leave it just like this. You got two equations here, but three unknowns, a, b, and c. How is that possible? Well, there's another equation here. It tells you that a plus b equals 8. So really what you have are three equations here and three unknowns, which is kind of a pain to solve. One way you can do it is, if only it were two equations and two unknowns, I'd be able to solve it. Well, you can make two equations and two unknowns. You can kind of take pairs of these guys. So maybe this pair here, I can say 7a plus 2b equals c and a plus b equals 8. I could add these equations together. I could say my first equation, I'm going to leave it completely alone. My second equation, I'm going to multiply both sides of it by -2. And the reason I'm going to do that is because I'm kind of looking into the future, and I want, when I add these together, my b terms to cancel out. 2b and -2b cancel out. So I get 7a minus 2a leaves me with 5a, and then that must be equal to c minus 16. So by combining these two equations, I've ended up with a new equation that only has a's and c's in it. My goal is to get another equation that only has a's and c's in it. But that's going to be kind of tricky to do, because if I combine the two of these guys, well, I already did that one. So I have to combine this with one of these two equations. And it's up to me which of the two I combine it with. I think you can get the answer either way, but I'm going to combine this guy and this guy, but I'll have to do so very carefully. AB equals 15 and a plus b equals 8. I'm going to do a substitution method to combine these guys. But be careful, I want to substitute for b, because I don't want to end up with any b's in the equation that I produce from these two guys here. So this and this is going to go down here. I don't want to end up with any b's because I want to later put that together with this one. So I want to get rid of my b's. From this equation, I know that b equals 8 minus a. And from this equation, I have a times b, but instead of writing b, I'm going to write 8 minus a is equal to 15. So what I have here, this actually worked out even better. I have an equation that only has one unknown, the letter a. So I can solve for what a is equal to. And once I have what a is equal to, I can plug that in here and figure out what c is equal to, which will give me the answer to the question. To solve this thing, you have a product of things that equals 15. It only helps you to have something times something if it equals 0. So what I have to do is expand this first, get 8a minus a squared equals 15. and then subtract 15 from both sides of the equation so that you have it set equal to 0, and then factor. When you're trying to factor, it helps to have a leading coefficient that's positive, so I'm going to add all this stuff to the right-hand side of the equation to get positive a squared minus 8a plus 15, and that equals 0. I'll write it on this side so you can kind of see where all the numbers went. And then if you factor this out, you'll get a minus 3 times a minus 5 is equal to a squared minus 8a plus 15. Negative 3 and negative 5, their product is positive 15 and their sum is negative 8. So this tells me that either a minus 3 equals 0 or a minus 5 equals 0. So either a equals 3 or a equals 5. Oh, cool. So the answer is a here, 3 and 5? No. Because this is asking what are the two possible values of c. You found the two possible values of a. We can then take those and plug those in up here. 5 times 3 equals c minus 16. So 15 equals c minus 16. If I add 16 to both sides of the equation, I get c is 31. And that might be enough to answer the question. It looks like it is. My answer must be D here. But to prove that to you, I can take a equals 5 and plug that into this equation. 5 times 5 is equal to c minus 16. So 25 is c minus 16. Add 16 to both sides of the equation, and you get that c equals 41. That's a mess. This is going to take you a long time on a test. Is there a better way to go about this? Can you plug these values in somehow? Honestly, I'm not sure, and this video is getting pretty long, so I'm going to stop this here and just present this as one solution.